Well, good morning, everyone. It is so good to be back. Last year, many of you may have heard my talk virtually, but let's be honest, it's good to be back here in person. If you don't know me, I'm Daryl Ritchison. I'm the director of the North Dakota Agricultural Weather Network. That is our new logo. We had a submission online for competition, actually, and that came up to be our new logo for the year. This is a map of mainly North Dakota. And what's on this graphic, if you've never heard me explain this to you before, is that there are 20-mile circles around all of the stations that we have. Why 20 miles? There's been a lot of research that indicates that everything outside of rain, of course, because rain is only valid for that 6 or 8 inch bucket, it still humors me that every time it rains, and I mean every time it rains, I get complaints about our rain gauges. And someone will say, geez, Daryl, I had 1.5 inches. Your rain gauge only had 63 hundredths. And I go, well, where do you live? Well, I live like 1.5 miles northwest of your station. And then I always want to kind of bite my finger so I don't say anything mean and go, really? You don't understand that it could rain 1 inch across the street from my station? But every once in a while our stations do air. Honestly, I do appreciate when people call. But anyway, outside of that rain, everything else generally is valid to a 15, 20-mile circle. So that'd be relative humidity, wind speeds, all of that stuff that we use for crop guidance. My goal since I became the director of NDAWN is to infill all the white. And if you look very carefully, if you're sitting in the front row and can see, you'll notice there's some 2023s in there. We do have station plans going forward with a large grant I got from the Army Corps of Engineers to infill. But if by chance you live in an area in white, I would very welcome a conversation with you. This is my Minnesota stations. I have 33 sites in Minnesota. All the sites, especially down here in central Minnesota and Hastings, Minnesota, of all places, are through the Minnesota Department of Ag. Some stations that we've taken over to assist them going forward. So 33 sites in Minnesota. Total, I have 168 stations now that are full stations. And then I have 4 rain gauge only sites. And those 4 rain gauge only sites actually have cameras on it. And that's part of a project that we've been doing up here in northwestern Minnesota, dealing with the oil industry and the local counties up there to help monitor, especially roadways, amounts of precipitation out in that part of the state for a number of different reasons. NDAWN is a mesonet. Meso meaning middle, net being network. We have 2 types of stations in our mesonet. This on the left is our tower station. The official World Meteorological Organizational height for measuring wind is 10 meters, which is 33 feet. NDAWN measures wind at 3 meters or 10 feet. And the reason that we do that, and I see we lost the signal, there it comes back, is 3 meters is a much better height in agriculture. You're measuring right off the top of the crop canopy, especially when it deals with corn. But other crops, grains, soybeans, it's a very good height to measure. So when we're doing our evaporation potential maps and some of our guidance, it's a much better speed. So on our towers, we'll have both wind speed heights in place. But this is what our tripods look like. And again, that's at the treatment, but all the surface data is the same. Many of our stations now also have soil moisture probes in place as well. So what exactly is NDAWN? I always like referencing as a weather risk management tool. And I'm going to give you an example from Minnesota. This past summer, I had a meeting down in Fergus Falls with some individuals, and their main concern was white mold in soybeans. They had hit very hard in 2020. So in 2021, they want to add some stations in that white area that I have in western Otter Tail and Becker County. On my way down to Fergus Falls that day for this meeting, I noticed a lot of fields were being sprayed. The soybean fields are being sprayed. I knew what was going on. But when I got to the meeting, I asked, so, what was everyone spraying on their soybeans on my trip down here? And they said, fungicide. And I said, why? Well, geez, Daryl, our meeting about white mold. I go, why? Think about it. Why were they spraying for fungicide on their soybeans when it's 86 degrees and relative humidity is 30% and the weather's not going to change for the next week? There is 0 risk of white mold on these soybeans in the next 10 days. And in turn, how much is it costing them per acre? They told me, did a quick calculation in my head, and I go, so Western Otter Tail County is spending $4 million on fungicide for the white mold on soybeans that will serve no purpose. I have a swimming pool in my backyard, and I said I routinely have to burn $100 bills. The farmers are burning a lot of $100 bills. And they go, well, Daryl, thank you. I mean, this is why we're here. We're trying to develop a white mold so such instances won't happen. $4 million, I could put 100 weather stations in Minnesota, and they use that in one day. That's a weather risk management tool. What NDAWN is trying to accomplish is to bring return on investment and investing in our weather technology, which in turn will bring more dollars and less wasted dollars, then in turn higher profitability. I had a large meeting with a group in Minnesota, it's down in the Twin Cities, with a group of bankers. And in this bankers meeting, everybody before I spoke in this bankers meeting was talking about why they needed to have good customer service, how they needed to get out of their office and out to the farm, talk to people individually. Good talking, good speech. When I got up there, I said, hey, everyone before me was talking about a very similar scenario. My question to you is this. Have you ever thought of investing in a weather technology? Because if you invest money, for instance, at $4 million that one day in western Otter Tail County, and when I asked them, why are they spraying today? Well, their fungicide dealer told them to. Hello, no surprise there. I go, but that $4 million could be $4 million that they repay back all of your loans at your bank. So instead of just thinking customer service, do you ever think of helping with technology going forward to help everyone out on their bill payment? And I think in some ways, I blew their minds because the room went dead silent. And having a room full of bankers go dead silent is like a room full of meteorologists going dead silent. It doesn't happen all that often. Anyway, the weather risk management tool. So really, again, we're just using weather data to predict the future. Really what weather risk management is being proactive instead of reactive. Being proactive rather than being reactive, going forward through time. So economic gain, more profits, and of course our use extends way, way beyond agriculture. Water Resource Boards, the Weather Service, which is just a couple of miles from here, uses it. We're used in emergency management. We're used widely throughout the area, a number of different uses. This hangs on my wall. If you heard me ever give a talk, you probably have seen this. This hangs on my wall. You don't get points for predicting rain, you get points for building arcs. That's being proactive instead of reactive. Everyone was mocking Noah when he was building the ark, but he was looking towards the future, not today. Anyone can forecast the weather today, generally speaking. Oh, the clouds are getting dark, it's going to rain. But what's on the horizon going forward? And that's what NDAWN is trying to accomplish, and I remind my team of that all the time. These are the three main websites you can get our data from. If you want to get your phones out, you're very welcome to take a picture of that. NDAWN.info is a new website for us, and then this cloud.ndawn.org will actually take you to a site that's just full of names. They'll have North Dakota, you might have to scroll down the list to get into Minnesota, but every station has its own specialized cloud service. So lots of graphs, tools that you can use on those pages, plus the sites that have soil water data or soil moisture data that most people have. This is the best site to actually get that. And this is a good example. This is Alvarado, just up the road. We put this station in on May 3rd of this year, of 2021, in association with Crystal Sugar and some local farmers in that area. And this is the concept of soil that confuses people. If you look at how water moisture, that moisture in the soil is measured, it's in this concept called volumetric water content. What volume of the soil is water? And so people will see it and go, oh, it's 25%. That's kind of dry. But that's 25% of everything. What's most of the soil is solids. So you really, in a nutshell, you have solids, water, and air. So 25% is actually pretty good, if you think about it. If you live in the Red River Valley, the clay, you can get over 50% because we're shrink swell. You know, as I always say, the clay in the Red River Valley of Lake Agassiz is a living, breathing organism. I was on a short vacation this past summer for just about 4 or 5 days, and when I got home, I had to mow. And when I got home to mow, I have to lift up my gutters. And when I went, I'm just, you know, you do so many things in life without thinking. I was going to lift up my gutters and put that top on. But when I did this, I didn't reach. And I looked up and I go, huh, it's way up there now. What happened? My soil shrank because I'm in the clay. And it hadn't rained in 10 days. So everything just shrinks. Well, it started to shrink. So later that day, guess what? Daryl's out there with a hose watering his foundation. My neighbor comes over. Daryl, you're a strange lot. You should have me as a neighbor. I won't even tell you the story of what me out in my pajamas at 2:30 in the morning the other night. Ask me afterwards. And he goes, what are you doing? And I go, his name's Gary. I go, Gary, I'm watering my house. I'm trying to get the soil to expand back up. What? I go, Gary, you've lived here your entire life. Your house, you've been living in your house for 30 years. You know, shrink swell, you're watering. You don't want the soil, the clay to move away from your foundation, and then you're going to have problems. So I'm just getting everything to expand back up. He just shook his head and walked across the street back to his house. Well, my soil expanded. I could reach the gutter the next day. Everything worked as well. Secretly, 4 days later, I saw him in his backyard watering his house. But anyway, this whole volumetric water content confuses people. Because here's the thing. There are soil types where you will never get 20% volumetric water content. It's a very sandy soil. I can take a hose and sit there forever, and it will never get there because it's just going to keep continually draining on down. Whereas Fargo clay, or anywhere in the Southern Valley, or the clays here in the Northern Valley, 20% is pretty dry. So it depends on the type. So 20% volumetric water content means something different for every soil type. So in turn, one of the people that works for NDAWN has a master's degree in soil physics. So what she's done is gone through every site, that particular type of soil, and came up with this concept of soil saturation. And so this will give you a much better idea in your soil type, or the NDAWN station close to you, what's actually going on. But there's a really key thing here. This time of year, right up there. You'll notice at 2 inches, at Alvarado, it's only 10%, which is pretty dry. Here's the thing. Notice the temperature is below 0 Celsius, which means it's below 0 freezing. It's invalid. Before it froze is at 40-50%. So really, Alvarado is doing wonderful for soil moisture and saturation. But I want you to remember, if you're going to go home and use this in the wintertime, if it's below freezing, But if you go on this page, you'll see little calendars by the graph. You can go back in time and see, where was I before it froze? And then you'll have a good idea, because it's going to stay there and go back to it when we get into next spring season. This black line, this is temperature on the top here. This is temperature, so we'll ignore this. But the blue line is actually the soil moisture, the soil water. And you'll notice the time frame, really June and July through this stretch. Notice it went down really, again, this is clay in the Red River Valley. Alvarado never had a water problem in the soil this summer. Above the ground they did, not in the soil. But notice when we got the rains, how it spiked on up. And now we're sitting really back to where we were last year. But again, these are tools available on that cloud service for everybody for free if you want to use these going forward. So I just wanted to do that. And then we have my inversion app. Everyone thinks of the inversion and spraying dicamba. And truth be told, this is why the Minnesota Department of Agriculture, that group, their #1 reason for wanting to get their stations in central Minnesota on our network was for dicamba and for our inversion app. It is still a one-of-a-kind, nowhere else on the planet that I know of can you get an alert that there's an inversion in your field. Thanks to the North Dakota Soybean Council, the North Dakota Aviation, and the Minnesota Department of Ag, all sponsoring money to get this done. Here's the thing. This thing right here has nothing to do with inversions. It's delta T. What the heck is delta T? Except maybe a new offensive scheme that the Minnesota Vikings could use that they would actually win. Or their delta T would be delta defense, which they lack sometimes too. But we won't talk about that today. But anyway, delta T is a way of measuring relative humidity. It's really the wet bulb, the dry bulb minus the wet bulb, which I just confused 500 people. Dry bulb is the air temperature. Wet bulb is if you got out of the shower this morning, you felt cold. Why? Well, A, the water is 120 degrees. Yes, but the other reason is all the water is evaporating off of your skin. Evaporation is a cooling process, so it's going to make you feel cold. You can go in Phoenix, where it's 115 degrees in the summertime, jump out of the pool, and you'll have goosebumps all over you, because relative humidity is 12%. The delta T would be 45. But what this really is telling you is it's a more precise measurement of the moisture content in the air. So when you get up here too low, delta T's are low, you're spraying, say, a herbicide. Because the plant's already somewhat saturated because it's really high relative humidity, none of your herbicides getting absorbed by the plant very well, so you're not going to get very good coverage. When you're in the green is ideal, but then when you get to the low humidities, which we saw a lot of this summer, is that when you're spraying, then you're getting a lot of evaporation. So you're spraying fungicide. What are you doing? Very small droplets, and you're just pouring it out. You just want to cover that entire plant, but because you're using a very fine nozzle, if the delta T's are like 20, 30 or above, this past summer we had delta T's in the 30s, but when you're getting up to 20, you just get massive amounts of evaporation. So the fungicide is just evaporating into the air. So then you go, wow, that whole treatment, all that money I spent was just wasted time. I've talked to numerous farmers who've told me, oh, that would explain when I put herbicide down on that dry day, I got horrid coverage and nothing died because I lost it all with evaporation. So delta T is just an economic tool. There's no laws, rules, nothing on this. Again, we're building ours. We want to get ahead of the game in NDAWN. So we built and designed this to help you understand. Let's be honest. We live in a windy climate. We spray when we have to spray. But this is an additional tool that maybe you can change your nozzle size if you need to go forward. NDAWN.info has a set scale at the bottom. Our main website does not. These were the minimums yesterday. If I would have shown you the minimums this morning, nothing exciting happened this morning. It was nice and mild out. You'll also notice NDAWN.info, there's zooms in for the Red River Valley if you want, a zoom in to our Minnesota sites, a zoom in maps out west. These are mainly current information. On NDAWN.info, we also have tools available for everyone out there that aren't available on our main website, like winter precipitation, for instance. We have about 26, 7, we put them in so fast that even as director I lose count, that have just winter precipitation only. We have things out there that can measure the amount of water and snow at many of our sites now. You can look at that. You can look at the 10-meter wind heights that we have available out there as well. And we also have station photos that we have available for everyone as well. So if you want to look at some of our photos, if you're traveling, for instance, there's always the opportunities to see, say, what's happening at your destination, because we now have, I do believe it's 71 NDAWN stations that have cameras associated with them. Here's an example. We've all heard that you're 6 degrees of separation for all human beings, right? In North Dakota and northwestern Minnesota, we're generally 1 degree of separation from everybody. This is out by Devil's Lake. This is Maddox, southwest of Devil's Lake. After this gentleman did get out of the ditch safely and left, I zoomed in the camera and I did notice the snow was yellow as he was leaving. Number 2, because 1 degree of separation, I put this on my Twitter feed for entertainment purposes that day. And of course, by noon, he was getting yelled at by his wife for driving too fast. Everyone knew who this person was within an hour and a half. Again, in this part of the world, we tend to be 1 degree of separation from everybody. Notice what that is on the screen? That is a tornado. Odd to say that we had, at one point this summer, only 4 tornadoes in the entire state of North Dakota. That did end up climbing. But at one point, we only had 4 tornadoes. NDAWN captured 2 of them on our cameras. This one we reported to the National Weather Service in Bismarck, and funny story, they didn't believe us, that there's a tornado there. And I'm just thinking, oh yeah, I've only been a meteorologist for 33 years. I don't know what a tornado looks like. But anyway, I do understand why they should question things. But anyway, that was a tornado that we captured. And the interesting thing is, one of my staff members and I have always thought, do you think we'll ever get a tornado and ever on one of our cameras? And my staff member and I go, yeah, maybe sometime in the next 10 years. That'll happen, of course, the next week. So anyway, that's a tornado that we captured. That's my NDAWN background. Let's get on to 2022 and beyond. Why dry may dominate. I know what you're all thinking. Daryl Ritchison, someone already said this to me this morning. You're wrong 50% of the time. You still can keep your job. Why in the world would we ever believe you that you could forecast tomorrow, let alone 2022 and beyond? I'm going to explain that to you today, and maybe by the end of my talk, you will actually believe me. If you were listening to me last year, when we did this virtually, this was the map I showed you for 2021. This is my analog package. This is my forecast. I said I thought 2021 was going to be a dry summer, which it was. I also thought 2021 was going to be a warmer than average summer, which it was. Anyone in this room remember Daryl Ritchison saying, although, I don't know if we can get warmer than 2020. It was pretty warm this summer. I said that last year. I was wrong. We were warmer than 2020 in turn, but I did get the warmer part right. That's Daryl Ritchison trying to be too specific sometimes that gets me in trouble. This was the 2021 from average, the actual numbers below average. Most areas over the summer were anywhere from 2 to 5 inches below average over the course of time. You will notice, though, that unlike some other dry years, we did have pockets out there this past summer that had sufficient rain. Not every single spot was drier than average this past summer. This is the percent of average, and again, there were some pockets out there. And I know what you're going to say, well, Daryl, a lot of that came in one day. What summer is that not true? We only average between 10 to 12 inches in the core of our summer. And how often do we get a 2 or 3 inch thunderstorm? That's 30–40%. That's very typical for us here. And we're dependent on that. That's what many of us were missing last year, this past summer, was that one good event to get us forward. A lot of talk about 1988 and 2021. I'm not here to please. I'm not arguing with anybody. I'm not telling you it wasn't dry this past summer. I'm just entertainment here, folks. 2021 versus 1988, a reality show that the Discovery Channel does not have. Okay, ready for this? This is 2021 NDAWN stations and cooperative stations. All right? Same scale on the bottom. You can see the rain if you're looking in the front, and you can see this. We couldn't use all the graphics because of some technical errors. Now I'm going to show you 1988, same scale, so the colors in the background will work. I apologize, there will not be any data from Minnesota on this next graphic. There's 1988. 2021, we probably had 20% of the area that actually had average or above average precipitation. 1988, we had 0%. That I think there's probably a spot, but we don't have it in. So there was really, and 88 was actually warmer, more extreme. So if you want to compare 2021 versus 1988, 1988 wins by a landslide. 1988 for the win. And again, your farm may have had a worse year in 1988. I'm not going to say otherwise. I'm just saying generally, region-wise, there really wasn't a comparison to me going forward. So this is October 2021. the Great Reset. You know what October 1st is? October 1st is the beginning of the new water year. What is the water year? A water year is really that reclamation of what you use during the warm season. Then you start all over in October, because most of what falls in October and beyond stays with you till the next year, and then the next spring comes, you reuse it up. It's a very common terminology used in hydrological circles. This was just October. Pretty much everyone, with the exception of northwestern North Dakota, so all of North Dakota, northwestern Minnesota, had a wetter than average autumn. And it was warmer than average. In many ways, it was an awesome autumn. Yeah, harvest was delayed because the rains were mistimed at times, but that's just the reality of where we live. Never get it perfect. But you'll notice this bullseye at our Fingal station right there, nearly 9 inches of rain in just the month of October. Oddly, in 1988, a very similar thing happened in the almost the exact same spot in southeastern Barnes County. Weather does not repeat itself, but it does rhyme. Just saying. But anyway, soil conditions now are awesome. We're going to start 2022 with great soil water conditions. Almost everyone. Yeah, there's spots up there. There's always spots up there. But we're going to start 2022 off really, really well. We'll start off really above average, but I want to explain here quickly what exactly the word average even means, because average has a definition, and what I'm about to explain to you is why my title is 2022 and beyond, why dry may dominate. All right, here's the definition. The definition is the past 30 years in whole decades. So on December 31st of this past year, our averages on December 31st, 2020, were based on 1981 to 2010. On January 1st of this year, we started a new decade. Everyone thinks decades start with zeros and end with nines. Technically, that's inaccurate. The millennium did not start on January 1st, 2000. That's when we all partied. But really, technically, it started on January 1st, 2001. Big whoopee thing. It doesn't matter when you party, all right? But in climate circles, because we're using the technical definition of a decade, January 1st, 2021 started a brand new decade. So on January 1st of 2021, our averages now are based on 1991 to 2020. What did we do? We replaced the 1980s, mostly dry decade, with the 2010s, mostly average or a little bit wet at times. So we made this big adjustment. Now, Daryl Ritchison, if you ever hear my talks, very basic graphics, I talk over pictures, there's no death by PowerPoint when you watch one of my shows. I'm going to give you the closest thing to death by PowerPoint you will ever see me do, and if you're sitting in the back, you're not going to be able to see this. This is the 30-year averages for Fargo, Bismarck, Grand Forks, Williston, Dickinson, and Bowman, really summation the Northern Plains, and I also am going to show you something from the Twin Cities coming up. And you'll notice this is how every decade, this is the end of that. So our current averages are right here based on ending in 2020. So these are ending in these years. You notice Fargo jumped an inch over the last year. Grand Forks jumped an inch from the new averages going forward. And you can see this going through time. So everyone's precipitation averages jumped. And if you go back to like 1990, you'll notice, we've jumped 3 or 4 inches. And again, it depends on the location, but generally speaking, 75 to 80% of the precipitation averages come in our warm season, April to October, those 7 months. November through March are generally phenomenally dry months. Most of us average more in June than we do from November to March total. That's how dry our winters tend to be. So notice through time how our averages change. And you'll also notice Fargo, it was wetter in 1910 average than in 2020 average. If I could take my DeLorean, my time machine, back to 1910 and say, hey everyone, this is the highest average Fargo's going to have for 100 years, they would have taken me away in a straitjacket probably. Not believed me, rightfully so. But it was. I'm here today in front of a lot of folks going, are these the highest averages we're going to see during this entire century? I would not actually be surprised if you look at proxy data and if you look at other tools that are out there and available. How does this differ? Again, the scale is the same, folks. Look at the top right there. That is 1991 to 2020. That's the new average. Now, these are NOAA statistics. They do not use NDAWN. Trust me, I'm trying to get them to use NDAWN data. But they do not. So there's the average. The scale stays the same. Notice it's just red is dry, blue is wet in the sense of average or above average. This is 1991 to 2020. I'm going to switch us back to our old average, to 1981 to 2010. And notice how the reds faded away to yellows. Now I'm going to go back and use 1971 to 2000 averages. Again, now notice northeastern South Dakota went to white. Okay. Notice some areas in Iowa went to white. We went some yellows. We're still getting back closer to average. Now here's the 20th century average from 1895 to 2000. And notice how we went to yellow. A lot of folks are only an inch and a half below average based on the long-term average. And if we want to use statistical tools, where do you rank out of 130 years of records? You will notice these are just precip ranks. How most of us were just barely outside of one standard deviation. Again, I'm not arguing that we weren't dry. I'm not arguing that you had a horrible year. I'm telling you, wet and dry is a perceptional thing based on averages that change over time. What you consider dry, your grandfather or your dad would have considered just on average, it's a pretty good year. Because over the last 30 years, during this wetter phase within our climate, this is the new normal. New normals don't exist in my world. We've had wet and dry cycles for the last 10,000 years. Devil's Lake has gone dry in the last 1,000 years. Nothing was there. Devil's Lake has overflowed into the Cheyenne River naturally in the last 1,000 years. What caused that? It's not what people are telling you today causes things. It's more complicated than that. The answer, by the way, is we don't know. I'm the one that's honest and will tell you the truth. This is Grand Forks average precipitation. Grand Forks has records going back to 1893. This center line right here, that is the average based on all the years. This is about almost 120 years average. Okay. The green are above average. The yellow's below average. Two things to notice on here. Number one is there's somewhat of an even distribution here, above and below. But also, how many of the lines are short? Pretty much none. Average doesn't exist when you live here. You're either going to be, those solid lines here are 5 inches. It's very common for us to be 5 inches above average this year and 5 inches below average the next year. It's all average, statistically, going back and forth. So what I'm going to do now is I'm going to take Grand Forks and I'm going to show you all the data since 1893 based on the new 1991 to 2020 average. You ready for this? Hold on to your chairs. If you're standing up, brace yourselves. Seriously, seatbelt buckles. Come on, people. All right, here we go. Boom. It's all yellow. Only 29% of the years since 1893 has Grand Forks been above the current 30-year average. I want to take every single one of you to Las Vegas with me this afternoon. Forget about all the sessions going on. Just rent a few airplanes, head on out there. And we have a 71% chance of beating the house. Are we ever going to leave Las Vegas? No. We're going to be rich beyond our wildest dreams. So, 2022 and beyond, our current averages are going to be with us until January 1st, 2031. What are you going to bet next summer it's going to be? And you might think to yourself, well, geez, Daryl, it's just going to get wetter and wetter here. It's never going to dry back off again. A, I don't know the future. I'm just crazy enough to forecast it. And I'm crazy enough to forecast 2022 in early December. Most summer forecasts you hear will be given next year on Memorial Day weekend. Daryl Ritchison by then will be moved on to 2025. Yeah. Anyone can forecast the summer in early end of May. Doing it in December here is a challenge. More entertainment. So I don't know. I would argue with you there's a lot of reasons that that's not going to occur based on proxy data. So again, this would mean 7 of the next 10 years of this decade, if I come here, I'm going to tell you it's going to be drier than average. We're going to do the same thing for Fargo. Fargo goes back to 1881, so 140 years of records. Again, you can see, wet, dry, wet during that time period, which is the case in most of this data I'm going to show you. Here's Fargo now. I switched it over to the current 30-year pattern. Fargo, like Grand Forks, 29% above that. Same thing, so 70% chance that any given year this decade is going to be below that average using statistical tools. This is Bismarck. This one's going to be crazy. Here's Bismarck, goes back to 1875. Bismarck was keeping records when Custer was there. That's how far back the records in Bismarck goes. The longest continuous records we have in the state of North Dakota is in Bismarck. I just switched it over. Did you notice? It's all yellow. This is crazy, folks. Only 19% of years in Bismarck have been above their current 30-year average. Please, send me to Bismarck every winter for the next decade. I'm going to look like I know what I'm talking about. Awesome. Thanks for laughing, by the way. No one else. 19%. Well, here it is. Let's take you down to the Twin Cities. It's the longest records in the Midwest, by far. They have records from Fort Snelling back in the 1820s. Still the weirdest thing ever, the first year at Fort Snelling, they got hit by a tornado. Just what are the odds? Those poor folks. But anyway, this goes back, official better kept records to 1871. So 150 years of records. There it is, based on the long-term average. And then I'm going to switch this over again, like I did the others. This is the current 30-year average. You notice Twin Cities the same way. In many ways, again, wet, dry, wet. Okay, cycle there, folks. Going forward. Twin Cities is 26%, so really we have about a 75% probability of it being drier than average. So again, 2022 and beyond, why dry may dominate, we have the 70% probability of every year going forward being dry. But is it dry? I would say no. I grew up about 40 miles from the Iowa border, down in Elysian, Minnesota. Have you ever heard of Elysian, Minnesota? I'm heading there tomorrow, in fact, to visit my mom for Christmas. Of course, big snowstorm down there because I attract that, like flies to honey type stuff. So I'll get to drive through 8 inches of snow, and then my mom will still be disappointed that I didn't get there in time. And I go, Mom, it was snowing. I had to drive 35 miles per hour. Well, you said you're going to be here at 7 o'clock. I go, Moms. My favorite emoji, I go, sorry, Mom. I'm a really bad son for driving through a blizzard and a snowstorm to get to you. But anyway, because I grew up about 40 miles from Iowa. You know, where I grew up back as a kid, if you get 100 bushels an acre corn, woohoo! And then 200 bushels an acre, woohoo! Well, the average in the state of Iowa is 200. But no one gives a hoot until you get about 350. You know, you're not going to get a free beer in northern Iowa until you get like 350, 400 bushels an acre. There are areas in Iowa, because I was doing some talks this summer about, wow, look how dry they are.
I go, yeah, they're dry by the current average. They're not dry historically. They're still going to get 250, 300 bushel an acre corn there, which they did. But if you look at the charts, you know, well, they should have. They were 3 inches below. No, they're 3 inches below the current average, not the long-term average. So if you're playing the markets, folks, I'll give you a big tip. The drought monitor for the next 10 years is going to be based on what I would call bad data. And a lot of other things. Look at the precipitation totals, not the percent of averages or above or below. Because again, this whole 75 to 80% or 66% stuff is not just in North Dakota, South Dakota, and Minnesota. It's also in Iowa, Illinois, Indiana, and Ohio. Because this wetter phase within the climate has been a big regional thing, not a localized thing. So it's just a tip for you going forward. Okay? History does not repeat itself. That's right. So, very quickly as I finish up, I want to get us into next year's forecast. So, this is the El Niños, La Niñas, the oceans in the Pacific Ocean since 1950s. These are all the El Niños. Matter of fact, I should be a better human being and make those in red because this is warmer than average years. And blue down here, colder than average. You notice here, we're double dipping. We had a La Nina last year, we had an El Nino La Nina this year, 2 years in a row. Again, almost all the heat capacity, 99% plus of planet Earth is in the oceans, not the atmosphere. Okay? This takes you back to the middle of August, and I'm going to run you a loop. Again, blue is below average, not necessarily cold, below average. You can fall off your ship down here in the blue, and you'll be just fine. You fall off a ship up here in the red in your Speedo, and you're dead in 20 minutes. Because think Titanic. It's above average, but it's still only 43 degrees. Still bitterly cold water. So keep that in mind when you look at it. These are anomalies, not actual temperatures. But you notice this is where El Niños and La Niñas are measured. And again, why is that important? Where's the surface area of planet Earth? Near the equator. We're round. So there's far, far more surface area between 0 and 10 degrees north than there is between 80 and 90 degrees north. And because the oceans are 70% of the planet, you know, what happens in the oceans doesn't stay in the ocean. To steal a phrase from Las Vegas. So with a La Nina going on, but here's the thing. Last year, most forecasts were for, oh, the winter is going to be cold and snowy. Because there's a La Nina. My argument, X does not equal Y. X does not equal Y. It's not that simple, folks. My forecast for last winter was near average temperatures and dry. Even my forecast for the dry part was right, but the near average was wrong. Yeah, we had 2 cold weeks in February. Last winter was about as good as they get in these parts. It was one of the warmest on record if it wasn't for those 2 weeks. But here's the thing. Look up here. Okay? Notice all that blue up in Alaska? So here are the surface temperature anomalies last year versus this year. Notice the Pacific Ocean where our weather comes from. Notice this over this. They're nowhere near the same. You don't need to be a meteorologist. Would you expect the same weather as last year when the oceans aren't even close to the same? Even the Atlantic Ocean is different. And I've explained here before, the Atlantic Ocean is important. You may recall, I think I said this last year virtually, I do recall saying it when I was here in person 2 years ago, the Atlantic Ocean is that semi, that tractor trailer that's in front of you. Didn't happen to me this morning on my way up to Fargo, but a lot of times when I'm heading down the interstate, there's a tractor trailer passing a tractor trailer. And this guy's doing 68, and this guy's doing 71. The speed limit's 75. I want to go 75. I'm in a hurry, but I can't go anywhere because I'm blocked until this guy passes the other guy, which sometimes can take 2 or 3 miles. So you just sit there behind. What's slowing me down? Wasn't what's behind me, the Pacific Ocean figuratively. The Atlantic Ocean, precipitation-wise, plays a big factor in our weather, especially in northern Minnesota and in North Dakota. So it is important to look over there. So you wouldn't expect the same weather. And the thing is, here's the odd thing. That storm we had last week, believe it or not, that's 25% of our moisture this winter. 25%. There's going to probably be a big storm again next week. Will it hit us? Will it hit Bismarck? Will it hit the Twin Cities? I'm not that good. But I think it's going to be a big storm, and if it hits us, guess what? We'll be over 50% of our moisture for winter by the middle of December. It doesn't take much here to get you going. So a pattern change over what that we saw actually during the course of last year. So here's the upper level wind flow in 2021. Notice these lines, these colors, is really, think of it as the wind direction. So here's the wind direction, just doing this. Wind direction, wind direction. Our flows from the northwest this summer. How much moisture is up in the prairie provinces of Canada? That big giant ocean up there, beachfront property. Northwest flow is our dry flow. 1936, that extraordinarily hot stretch that either maybe your father, in my case, or your grandfather told you about, the wind was blowing from the northwest. 121 in Steele, North Dakota. What did the co-op observer say about that day? Hot winds, leaves and shrubbery cooked, was her comment and her form for the weather that day. By golly, I bet you it was. But what was that hot wind? It was blowing from the northwest. We think of it as a cool wind, but it's not oftentimes. So that was the pattern that year. And then this was the pattern, say, in 2019. You know, Tom had mentioned about all the wetness this year, but notice the difference. It was coming more like this. Here's our moisture, okay? This is why we farm, okay? That moisture coming up in from the Gulf of Mexico catches in those storms. When storms like clippers come in, and then what we had last weekend, by the way, wasn't technically a clipper, but when you have clippers coming in, there's no time for it to catch up any moisture from the Gulf of Mexico. But when they come from the southwest, which is the storm that's going to head down to the Twin Cities tomorrow, and maybe this area next week, it has time to pick up moisture because it's tracking like this. Here's day 1, day 2, day 3. It has all this time to pick up that moisture. Southwest flow, most of this wet phase of our climate that we've been in has been associated with southwest flow. And so in turn, that ends up being very, very important as we move forward. So anyway, this are my analog sets for 2022. Well, Daryl, I could have come up with that same analog set. These are past years, similar to this year. Well, of course it's going to be drier than average. You has told us a 70% probability, right? You are correct. Notice what it's based on. It's based on 1991 to 2020 up here on top of the screen. But this is now, I just switched it. Now we're based on 1895 to 2020. Both short-term average and long-term average, it looks drier than average for me for next year. Temperatures like 2020, 2021, probably above average. I'll be foolish to tell you what I told you last year, probably not as warm as last year, but still above average, which is good here. We're a cool climate going forward. So I'm actually going to bypass something to ponder because I'm out of time. But I just want to sum it up for 2022. A great start, soil moisture. Really good start. Really good start, soil moisture. Here's the problem. We have a lot of moisture in the Red River Valley and some other areas. Spring flooding, not catastrophic, it's possible. A couple big storms. I'm not, anything's possible. But even if we had 2020, you may remember, we had flooding in the Red River Valley. Moderate flooding in many, many ways. So we get a couple of good storms this winter. I think there will probably be more excessive moisture problems in the spring than lack of moisture. Not the end of the world. We'll get out there. We always do. But then I think we'll transition to below average once again. So by the time we get into July and August, it'll be, where is the rain? Why isn't it raining? So in other words, below average rain, above average temperatures. Always a great joy for me to be here. If you have any questions, you're always welcome to contact me. My phone number is on the contact page on my websites. And I'll be out of the room if you have any further questions going forward. But thank you very much.